Terrance Howard proposed that one times one is equal to two. Now, I don't know if that statement is true or not, but today we're gonna go through the reasoning why he thinks that statement is true. I have personally uh, tried to figure it out myself, and I can't lie, I can see where he's coming from. I can see where he's coming from. Some people immediately just go like, "Oh, he's wrong, he's wrong, he's wrong," because he's wrong. It's This is just how it is. I mean, guys, at the end of the day, just try to objectively think about it, right? And understand where he's coming from. And if he's right, and we can make advancements. If he's not right, oh well, what do we got to lose? We're just reinforcing the statement, right? What is true, right? And to be honest with you, right, the main thing which I understand for most people is that if he is right, the whole of maths has to be rewritten. You understand? That means computers, calculators, most of the things that use maths, that use multiplication, might be wrong. Okay? These things might be wrong. Okay? And stuff like indices to the power of and stuff like that, matrices, vectors, the list goes on, right? But anyway, let's just get into the video, right? Okay. So he stated that one times one is equal to two, right? We don't know if that's true or not. But if we think of multiplication, right, from a very early age, this is what he also states in his book, and what I've personally come up with while before reading his book, right? And he also uses it to reference it, right? So, like, from a very early age, right, in elementary school or primary school, right, you guys have been taught that if you want to multiply something and you don't know what the answer is, you'll just use addition, right? So, like, let's say 3 times 4, right? If you have 3 times 4, we know that that's 12 because we just memorized it, right? Because we got it down like that, right? But if you don't know what 3 times 4 is, right, what you would do is add three, 4 times, right? So we do 3 plus 3 plus 3 plus 3, which is equal to 12, right? So 3 plus 3, that's 6, plus 3, that's 9, plus 3, that's 12. Do you guys not agree? So 3 times 4 is also the same as saying 3 plus 3 plus 3 plus 3. You guys agree? I'll give you guys one more example. Let's say 2 times 5. Actually, that's a bit long. 2 times 4, right? 2 times 4. We know that's equal to 8, right? And how would we figure that out if we didn't know if it was equal to 8, right? We'd do 2 plus 2 plus 2 plus 2, right? Which is equal to 8. 2 plus 2, 4 plus 2, 6 plus 2, which is equal to 8, right? So basically, multiplication is, for lack of a better word, an advanced form of addition, right? It's addition at a faster rate, right? If you guys still are a bit, okay, right. So if I could put it in better words, which I also looked this up, right? Multiplication is how many times we add a number onto itself, right? That's basically what multiplication is. And if you don't believe me, um, I got a bit of Google on my side here, right? If you don't believe me, okay. So here it states that uh, multiplication, Definition: multiplication, a mathematical operation that indicates how many times a number is added to itself, right? A mathematical operation that indicates how many times a number is added onto itself, right? So if we go back, right? If you go back here, right? If you go back here, right? So what we're basically saying when we say 2 times 4 is we're saying we will take we will add 2 4 times, right? So 2 plus 2 plus 2 plus 2. We in this case we will add 2 4 times. Do we not agree? Right? I know I'll I'll talk about something of groups of in a bit because some people say that multiplication is how many groups of in a bit, but don't worry about that, right? So so we agree, right? Multiplication is how many times a number is added onto itself, right? We agree with that, right? So let's go back to 1 times 1, right? If you go back to 1 times 1, right, what we're practically saying is we will add 1 once to itself, right? Which is 2. What we're basically saying in this 1 times 1 is 1 plus 1. Do you guys not agree? That's basically in hindsight what he's saying, right? I'm not a mathematical professor. I'm not. I I'm going to uni. I'm just explaining what I think of it, right? But if if the definition of multiplication is how many times you add a number onto itself, then this statement should be true. It should be true. Now, if it was a different definition, such as the number of groups of, then sure. But then you wouldn't have to use addition, right? Addition would be a completely different things, right? It wouldn't make sense. Right? But if you go by that definition, then fine. That makes sense to me. That completely makes sense to me. But then again, let's go back to 1 times 1 is equal to 2, right? If we say that 1 times 1 is equal to 2, right? I continued with this logic, right? What then I'm saying is 2 times 2 is not equal to 4. So 2 times 2 is equal to 6, I believe, right? Because here we're adding it once, right? Where we do 1 times 1 is equal to 2. We're adding it once. You see here, the first number we don't count. But in this case, the first number we do count. You see the disconnect here. Okay, okay. Let's go back to 2 times 2 is not equal to. If this is true, right? If this that I just stated right here is true, which hear me out, this is what I think, right? So let's say 2 times 2 is equal to uh is not equal to 4. The reason why I say this is because 2 plus 2 plus 2 is equal to 2 times 2. The reason why I say that is because in this case, where 1 times 1 is equal to 2, right? The first number we don't count, right? Because it's how many times we multiply, we add. So in this case, we add it once, right? But in this case, we add it twice, as you can see here. 1, 2. And if you know 2 plus 2 plus 2 is equal to 6, right? So 2 times 2 is not equal to 4. 2 times 2 is equal to 6. That means the whole multiplication is wrong. It's completely wrong. It's a lie. The whole thing is a lie, right? So it just puts your head into things, right? This is why I said that the power of indices would also be wrong. And the reason why I say indices would also be wrong is the fact that indices are basically multiplication, right? It's a higher form of multiplication, just as multiplication is a higher form of addition, right? So if I say 2 to the power of 3, what I'm saying is 2 times 2 times 2, right? And since the multiplication is wrong, then then the power of must be wrong, right? So that's the whole premise, the whole premise behind the multiplication table, right? So if you guys don't believe me, if you guys want to see um, more stuff about it, uh, I created a Python program to show you the multiplication, right? Just consider this like a normal calculator, right? So let me run it, right? So let's say I do 5 times 5, right? Times 5 times 5, right? It's equal to 30. It's not equal to 25. It's equal to 30, right? It's shifted, right? So the multiplication series shifted. If I run it again, 4 times 4, 4 times 4, right, is 20, right? Whereas before it would have been 16. So we literally shifted it by one more addition series, if that makes sense, right? So, and as you guys know, like I stated before, um, we know that 5 to the power of 2 is equal to 25, right? Right? In normal maths, right? But in this case, 5 to the power of 2 is equal to 30. So indices would be wrong, right? And like I just did, 4 times 4, right? Which is the same as 4 times 4 is the same as uh, 4 to the power of 2, right? Is equal to, what was it again? 20 is equal to 20. Just like 5 to the power of 2 is 5 times 5. It's 5 times 5, which is equal to 30 in this case, right? So that's the whole premise behind his logic, right? And my logic, because honestly, I don't know if this man is right, but I do kind of believe him. I just ask you guys to think about it logically, do your own research, and don't hate on the guy. The guy is not doing anything wrong, okay? And I think that's where he also says the square root of 2 is equal to 1. That's for another day, guys.